Hello, I'm Soumya and I'll do the question assigned to me. So let's get started. Okay, so let's first read the question. We need to do the double integration of cos y minus x upon y plus x dA, and it's for the points for the trapezoid 1, 0, 2, 0, 0, 2 and 0, 1. Okay, so first let's make the graph for this one. It'll be a quick one. So 1, 2, 3, 0, 1, 2, 3. So the first point is 1, 0, and that's 1, 0. Then 2, 0, 2, 0 would be here, 2, 0. Then there's 0, 2, and then there's 0, 1. Okay, so let's join it. So this is the area for which we need to calculate the integral. Okay, the equation for this line, if we solve, is y equals to minus x plus 1, and for this is y equals to minus x plus 2. It won't matter actually, but it's just for the solving purpose. Now the whole integration would be easy when we move on, but what becomes difficult is the number of variables. So for this we'll assign it to a smaller one. Let v be x plus y and u be y minus x. Okay, so you know what Jacobian is, and how do we find that? That's the determinant of the partial derivatives. Yeah, dv by dx. That's here d is del. That's what we call actually. Okay, so what does this mean now? J x comma y is del u by del x, del v by del y, minus del u by del y, del v by del x. Okay, so very quickly we'll do that. We know v and u is this. So for, let's see, del v by del x, that means keeping y as a constant and x as a variable. Okay, so what will that be? That will be 1. And del v by del y, that means keeping x as constant and y as a variable, it will again be 1. For the u, del u by del x, the same way, it will be minus 1, and then del u by del y, it will be 1. Yeah, so when we put up this, we'll get minus 1, 1, minus 1, 1. That'll be minus 2. Now that's not what we'll use. We'll use the Jacobian for u comma v. What that is the reciprocal for x comma y, and that's 1 comma minus 2. That's minus half. Basically that's minus half. Now if we are changing x comma y to the variable u comma v, we also need to change these points for u comma v. Okay, so let's do that very quickly. We'll do that here only, and then we need to make a graph for it for the better understanding, of course. So here's the x comma y, and here we'll change it to u comma v. So for 0 comma 2, right, when 0 comma 2 is there, v would be 2, v would be 2, and u would be that would be 2 minus 0, that's 2. Similarly, for 0 comma 1, it will be 1 comma 1. For 1 comma 0, it will be minus 1 comma 1. For 2 comma 0, it will be minus 2 comma 2. Okay, so now let's make a graph with this. That's 1 2 3 1 2 3 minus 1 minus 2 minus 3. Yes, so for 1 comma 1 it will be here, for 2 comma 2 it will be here, for minus 1 comma 1 it will be here, for minus 2 comma 2 it will be here. Yeah, so basically that would be the point that will make. Yeah, so what this line is, that's u equals to v. Yeah, because that's 1 comma 1, that's 2 comma 2, and here it will be u equals to minus v. Why? Because that's minus 2 comma 2 and that's minus 1 comma 1. Okay, so now let's solve the integral for it. I really hope that's clear. The v would go from 1 to 2 and u would go from minus v to v. What was the Jacobian? That was mod minus half. That's cos. The cos was y minus x upon y plus x. We assign these variables to this expression. So what it becomes? It becomes cos u by v. Yeah. So that's what we'll write here. We'll write cos u by v du dv. Okay. Very quickly, first we'll integrate this part, and then what the answer will come, we'll integrate with respect to v. Okay, so we get that the mod half minus half will be out because it will act as a constant. Okay, so let u by v be w. Okay, so dw would be 1 by v du. That's okay, and now if u is minus v and u is v, that's the limit. So w would be minus 1 and here w would be 1. So what will actually be the limits then? That'll be from 1 to 2, right? Okay, so let's dv. I just hope that this thing is that's v. I'm so sorry. This v wala cheese is clear because when we differentiate dw, v remains as constant here. Okay, so when we integrate this, cos becomes sine. So that's what we'll do. V remains outside. That's sine w, and I'm very sorry, it would be from minus 1 to 1 dv. Yeah, then we'll put on the limits here and we'll get sine 1. After putting the limits, we'll get sine 1. Now let's do it for the second integral, right? dv. Here 2 will get cancelled. Sine 1 will act as a constant. So sine 1 will be out of the integral v. V ka integral would be what? It will be v square by 2, because x raised to power n ka integral is xn plus 1 upon n plus 1 plus c. We will not use the constant here because we'll be putting up the limits. So here it will be sine 1 b square by 2, 2 to 1, and when after putting up the limits we get the answer 3 by 2 sine 1. Yeah, I'll give you a final review of the whole question. That's the first page. Okay, first we assign these values, we made the graph for the clear understanding, then we calculate the jacobian for x comma y, and then it's reciprocal for u comma v. That's what we are gonna use. As we changed x and y in terms of u and v, we will also change these points as we changed it. For the better understanding, we made a graph. So there are in total 2 graphs. Then that's the second page. Here we did the iteration, integral. For this, first we solved this part and then the outer part. We changed x and y to u by v, and then we changed it to w. So we also changed the limits here. And this all got solved. So this is the final answer that was required. I really hope you understand this question, and thank you so much. Let's meet you in the another video. So bye.